When you put multiple language model agents together to solve a problem, something surprising happens. The team consistently performs worse than its best individual member. This counterintuitive finding challenges a fundamental assumption about artificial intelligence collaboration. Let's examine why this matters for how we build AI systems. Building on that paradox, the researchers tested this across 2 experimental regimes. They found that large language model teams systematically fail to capitalize on internal expertise, showing synergy gaps from 8% on MMLU Pro to over 37% on more challenging benchmarks. This visualization captures the core problem perfectly. On the left, we see the expert consistently outperforming the team. No strong synergy emerges. The center panel reveals the mechanism. Agents engage in compromise-driven discussions rather than deferring to the expert, even when expertise is marked. On the right, a troubling trend appears. As you add more agents, performance deteriorates further. So what's actually happening during these team deliberations? Here's the behavioral mechanism at work. Analysis of conversation logs reveals that teams default to compromise, blending opinions to reach consensus. But this is precisely the wrong strategy when expertise is asymmetrically distributed. What they should do instead is practice epistemic deference, deferring to the agent with demonstrated authority on each specific problem. Scaling reveals an even more troubling pattern. The expertise dilution effect means that adding more agents to a team actually makes things worse, pushing performance further below what the expert alone could achieve. This holds regardless of whether you mix model families or keep them homogeneous. There's an intriguing duality here. The same consensus mechanisms that prevent teams from leveraging expertise also make them remarkably robust to adversarial agents trying to sabotage the group. This isn't accidental. It's baked into alignment procedures like RLHF that reward agreeable interactions. But it creates a fundamental trade-off between robustness and the ability to harness true expertise. These findings have profound implications for how we build multi-agent systems. Current approaches based on emergent self-organization simply don't work for expertise-dependent tasks. Moving forward, we'll likely need architectural interventions, mechanisms for detecting and respecting epistemic authority, new training paradigms, and possibly hierarchical structures that allow expertise to surface and dominate when warranted. The central lesson is stark. Large language model teams are robust but fundamentally limited, systematically underperforming their best member because they choose consensus over competence. To learn more about this research and explore other cutting-edge papers, visit emergentmind.com.